Sir Isaac Newton by Cindy and Jaden. Isaac Newton is an English physicist and mathematician who is widely regarded as one of the most influential scientists of all time. He is best known for his discovery of the laws of gravity. General information. Isaac Newton was born in Woolsthorpe, England on December 25, 1642. He died in London, England at the age of 84 on March 20, 1727. Newton's father, also named Isaac Newton, was a prosperous local farmer, but died 3 months before he was born. When Newton was 3, his mother remarried to the Reverend Barnabas Smith, leaving Newton in the care of his grandparents. At the age of 12, Newton reunited with his mother after her second husband died. She brought along her 3 small children from her second marriage. However, his mother pulled Newton out of school to work on the family farm. Newton had a strong dislike for farming, and his uncle eventually convinced his mother to allow Newton to finish his schooling. Schooling and college years. In 1654, at the age of 12, Newton attended the King's School in Grantham. Although Newton was initially regarded as a poor scholar, he eventually rises to the top of the class. In 1661, Newton attended the prestigious Trinity College in Cambridge. He was a Caesar, a student who received free lodging and food, similar to a scholarship. At Trinity, Newton studied mathematics and attended the lectures of Isaac Barrow, where he learned, among other things, of the methods Barrow used to determine tangent lines. In 1665, he obtained his Bachelor of Arts degree from the Trinity College, and in 1668, Newton was granted his Master's of Arts degree. In 1665, Newton developed the generalized binomial theorem while studying at the Trinity College. This theorem is a rule allowing the square of the sum of 2 functions to be written as a series of terms. Ultimately, Newton's binomial theorem led him to develop a method to determine the sum of a power series with an infinite number of terms, which eventually led to his formulation of the calculus. The Great Plague in 1665. Soon after Newton had received his degree, the university temporarily closed as a precaution against the Great Plague. As a result, Newton returned home to pursue his private studies. It was during these 2 years that he developed the majority of his theories on calculus, optics, and the law of gravitation. Newton made contributions to all branches of mathematics and produced simple analytical methods that unified many separate techniques previously developed to solve problems such as finding areas, tangents, the lengths of curves, and the maxima and minima of functions. Newton's theory of calculus built on earlier works by his fellow Englishmen, John Wallis and Isaac Barrow, as well as on work of other mathematicians such as René Descartes, Pierre de Fermat, and Bonaventura Cavalieri. Newton laid the foundations for differential and integral calculus. He is especially famous for his solutions to the problems in analytical geometry of drawing tangents to curves, or differentiation, and defining areas bounded by curves, or integration. Not only did Newton discover that these problems were inverse to each other, but he discovered general methods of resolving problems of curvature, embraced in his method of fluxions and inverse method of fluxions. Instead of using derivatives, Newton referred to fluxions of variables, denoted by x, and instead of antiderivatives, he used what he called fluents. Newton employed a notation called dot notation, which used a dot placed over the dependent variable that was to be differentiated. Newton considered lines as generated by points in motion, planes as generated by lines in motion, and bodies as generated by planes in motion, and he called these fluents. He used the term fluxions to refer to the velocity of these fluents. As the term implies, fluxional calculus is a method for treating changing or flowing quantities. So a fluxional represents the rate of change of a fluent, which is a continuously changing or flowing quantity, such as distance, area, or length. Newton's method. This is a technique used to approximate the real zeros of a function. The method uses tangent lines to approximate the graph of a function near the x-intercepts. The steps are repeated as the approximations continuously get closer and closer to the actual value of the zero. We should be pretty familiar with the general equation. Here is an example of a problem. Given the equation f of x equals 0, solve for x numerically. First, you make an initial guess, x0, and then go up to the curve. Then you draw the tangent line and determine its equation. Now, let x1 be the x-intercept of this tangent line, in which this intercept is given by the formula x1 is equal to x0 minus f of x0 over f prime of x0. Then you simply repeat the steps using x1 as the initial guess until you reach the desired answer. Newton versus Leibniz. There was much controversy between Newton and German mathematician Gottfried Leibniz over who should be credited for the invention of calculus, known as the Calculus War. Newton derived his results first, in around 1665 to 1666, but Leibniz published his first in 1684. Newton's full manuscript wasn't published until after his death in 1736, called The Method of Fluxions and Infinite Series. However, Leibniz apparently read a copy of Newton's manuscript during a visit in London in 1676. Newton charged Leibniz with plagiarism, and a long, intense quarrel began. Later mathematicians believe that Newton and Leibniz both developed the calculus independently, though the notation of derivatives and integrals employed by Leibniz is now preferred.
Created using Powtoon.